Hi, friends. I was theory crafting a good rag for research work, and this is where I am right now with it. Imagine you have a huge library the size of Connaught Place, with crores of books stacked floor after floor. If you want to study Indian freedom struggle, you cannot flip through every single book. That will take you years. Retrieval Augmented Generation, or RAG, was invented to save time by letting a computer first retrieve only the most useful documents and then pass them to a large language model. But here comes the problem. If the database itself has been tampered with or contains wrong information, then even the smartest model will confidently give you a wrong answer. So the template I'm working on is multi-layered and detective-like. Instead of simply searching and then answering, it applies several filters one after another. And in the revised design, the most important filter, verification, and self-doubt, comes right after the first retrieval step. That makes the whole system more trustworthy. The first stage, coarse retrieval, is like an express scan. Your question is converted into a mathematical object called a vector. A vector is just a list of numbers that captures the meaning of your query. For example, if you ask how to cook Rajma Chawal, the system does not literally remember the letters RAJMA. It turns the sentence into a sequence of numbers that represent the concept of food, cooking, and recipe. Then the system compares this vector with vectors of all documents. But doing this with billions of documents one by one would be like comparing your shopping list with every single product in Big Bazaar, exhausting and slow. So instead, it uses ANN, which stands for Approximate Nearest Neighbor. AN is like asking a shopkeeper in Carroll Bog to quickly point you to the 10 shops that most likely sell the kurta you want. He may not be perfect, but he is fast. Algorithms like HNSW, Hierarchical Navigable Small World, create a graph, which is like a city map, where each document is a building and roads connect similar buildings. The system then jumps along these roads instead of checking every house. IVF flat inverted file with flat index is like dividing a huge Mandy into sections, fruits, vegetables, grains, and only searching the relevant section. There is also hybrid search, which mixes vector search with plain keyword search. If you ask for Silk Road history, hybrid search will pull documents that mention the actual word Silk Road as well as those that talk about ancient trade, even if they do not use the exact words. Now comes the revised second stage, verification and integrity check, the moment of self-doubt. This stage is crucial because it asks, before I go deeper, can I trust what I just retrieved? Think of it like the guard outside your apartment building. Before you enter the lift, he checks your ID and verifies if you are really a resident or a visitor with permission. Without this guard, anyone could walk in and even reach your flat. Verification works in three main ways. First is digital signatures and cryptographic hashes. A hash is a unique fingerprint of a document created using a mathematical formula like SHA-256. Imagine when your Aadhaar card was issued, it was given a unique QR code. If someone alters your Aadhaar, the QR no longer matches the original. Similarly, when a document is stored in the database, the system calculates its hash and keeps it safe in a secure ledger. When the document is later retrieved, the system calculates the hash again. If the two do not match, that means someone tampered with it. For example, think about a rule in a government portal that says any transfer above 10,000 rupees must be verified. If a hacker changes it to no verification required, the hash will no longer match and the document will be thrown out. This prevents poison data from even entering the classroom. Second is source provenance. Provenance means origin, like where your vegetables came from. If you are buying pindi in Lajpat Nagar Sabzi Mandi and the vendor says it is from his farm, but you find the Mandi sticker still attached, you know he is lying. Similarly, the system only allows documents from whitelisted, trusted sources. If a medical database is supposed to contain only documents from AIIMs or ICMR and suddenly a random blog entry appears, this layer will reject it. Middle-class families can relate to this as checking if the milk packet is from Amul or from some nameless local supplier. Third is rule-based filtering. Even if the document is genuine, it may contain malicious patterns. For instance, if a financial document retrieved contains a hidden script or unusual keywords like ignore all instructions, this layer flags it. It is like your bank's SMS filter, which refuses to open suspicious links even if they look like ICICI or SBI messages. The point of doing verification so early is efficiency. If we let all documents, even malicious ones, pass into the next heavy stage of re-ranking, we waste precious time. Fine-grained re-ranking uses models called cross-encoders, which pair the query with each candidate document and judge their relationship in detail. This is computationally costly, like a tuition teacher spending 1 hour explaining a chapter. If the teacher spends that hour on a fake or useless book, then time is lost forever. By doing verification first, we ensure that only clean, authentic notes reach the teacher. Then the re-ranking model can fully focus on relevance without worrying about lies or manipulations. This design is especially important for adversarial environments. In friendly environments, like a home library where no one tampers with your notes, the original order of retrieval first, re-ranking second, and verification last works fine because speed matters more. But in tough areas like finance, healthcare, or government, where malicious tampering is common, putting verification early is like keeping the guard at the main gate rather than at your doorstep. For example, an ELEC policy document must be verified the moment it is pulled out. Otherwise, a forged line saying premium need not be paid after 5 years could slip through. So this is the revised detective flow. First, a course retrieval skims the huge data like a shopkeeper guiding you to the right lane. Then verification acts like a guard who checks ID and source before you waste energy reading. Finally, only after the dataset is clean, the re-ranking model comes in like a strict teacher sorting notes into the best possible order. The effect is a much safer, more trustworthy system that middle-class Indians can picture in their daily life, whether it is shopping online, banking, or even looking for medical advice on symptoms. By reordering the layers and giving verification its proper place, RAG becomes less of a hasty student and more of a wise investigator who doubts first and then studies. Let me know what you think.